Welcome. I'm Morgan Dutton. I'm a TPM with the SageMaker Ground Truth synthetic data team.
And my name is Herman Bergmeier. I'm a senior engineer on the AWS robotics team and one of the lead engineers for SageMaker Ground Truth synthetic data.
We're here to talk about creating high-quality training data sets for your machine learning models using synthetic data. Today, we'll step through the process of creating labeling data for machine learning and introduce new synthetic data generation capabilities available now through SageMaker Ground Truth. We'll talk about the benefits of using Ground Truth for synthetic data generation, and then we'll show you how it works. We'll highlight the business benefits, and finally, we'll share a couple of customer use cases. Let's review the typical machine learning process. First, we'll collect, prepare, and label the data. Next, we select and optimize the machine learning algorithm, and then we set up and manage the environments for training. Finally, we'll train and tune the model. This stage helps machine learning scientists identify specific gaps in model performance, which often leads to iteration on the previous steps rounding out the training data set, and tuning the model specifically to improve the accuracy of the machine learning predictions. Then the model has been tuned and is performant, we'll deploy to production. We scale and manage the model within the production environment with regular audits for model drift or bias, as data inputs or business needs can change over time. We're always iterating with machine learning process. We'll refresh training data or implement an active learning loop, regularly review low confidence predictions, and then retrain and tune again. Machine learning scientists face a number of data labeling challenges. Performant models need massive data sets of high quality data, and labeling data at scale is expensive and time-consuming. Label accuracy is critical to model performance, and annotators can make mistakes if instructions are ambiguous or if they have not been trained on more complex annotation modalities. Data prep, including data labeling for supervised learning, can take up to 80% of a data scientist's time. And all of this detracts from the higher value add work of training, tuning, and deploying those models. To help customers overcome these challenges, AWS offers Amazon SageMaker Ground Truth, a managed data labeling service, as well as Ground Truth Plus, our turnkey option, which handles the entire data labeling process on your behalf. Ground Truth enables you to sign into the AWS console, launch a labeling job, or alternately just use the AWS SDK to launch labeling workflows. We jumpstart your training data process and store with more than 30 labeling workflows for computer vision and NLP use cases. And the service also includes many machine learning driven features like assistive labeling, auto labeling, and annotation consolidation. You can use a range of workforce options to meet your business needs. And finally, you pay as you go with pricing per object. Essentially, this is a start to finish data labeling service that removes the undifferentiated heavy lifting of the training data process and lets machine learning scientists focus on what they do best. And since we're always looking for new ways to support our machine learning customers, we've partnered with a few other Amazon teams to support synthetic data generation for SageMaker Ground Truth. We're excited to bring this new capability to our customers. Let me give you an overview. This new capability helps data scientists and machine learning engineers leverage labeled synthetic data in their machine learning process without collecting large amounts of manually labeled data. We know that scientists typically run into 3 challenges when trying to collect and label their data. First, the time spent sourcing the data for machine learning is significant. Scientists can spend months gathering hundreds of thousands of images from production environments to capture all of the data variations a computer vision model will encounter. Second, it's expensive, and it can be impossible to source some images, particularly for rare edge cases, such as product defects. And lastly, creating accurate labeled data at scale is slow, and it's open to human error. With Ground Truth, we can easily generate large amounts of synthetic data and use it in combination with real-world data to generate more complete and representative data sets for your machine learning models. Training data services at AWS have evolved over the last few years. We started with Amazon Mechanical Turk 16 years ago, and from there we took a closer look at supporting more complex modalities with SageMaker Ground Truth. Shortly thereafter, we developed Amazon Augmented AI, which built upon the labeling workflows of Ground Truth, but added the ability to integrate machine learning models, making it easier to route tasks for human review based on prediction confidence. We then simplified the customer experience further with Ground Truth Plus, a turnkey labeling service. And finally, we're rounding out our capabilities now with support for synthetic data, which complements our suite of services by further reducing manual effort and cost.
Now let's talk about the benefits of using synthetic data in your ML project will have. As we've heard, typical ML projects require large data sets of labeled data. We believe that synthetic data generation can deliver these data sets faster and at a lower cost than traditional methods of labeling. However, cost and speed are only two aspects, and we think there are more to consider. We can set up specific situations to optimize your ML training outcome with our scene and object customization. Our scene and object parameterization generates variability in the large data sets to using controlled randomization. With synthetic data generation, the simulation engine has complete information about the objects within the scene. So we can generate the highest accuracy of ground truth available. Where synthetic data really shines is in the handling of rare situations. These are hard to identify in production, and we need to have a large quantity of them to make an impact in your model training. This is where synthetic data can really help. So let's talk about faster and lower cost. I think everybody who's familiar with manual labeling is familiar with the process setup of QA loops, and audits. These take time and cost money. For synthetic data generation, a higher initial effort is needed to get the digital assets ready for the simulation. But once that's resolved, the method resolves very quickly to large data sets. To get us even started quicker on your synthetic data project, we have access to a digital asset data set of more than 1 million assets that allows us to get started quickly. And these were created by artists at Amazon as part of their work. Within our simulation, we expose many parameters that allow us to customize various aspects in the simulated world. This can model your existing data set as well as future situations that you haven't encountered yet in production. Maybe you want to put your robotic or computer vision solution into a future location that isn't built yet. You won't have access to production data from this location. With synthetic data, we can already generate this data, and you can get started on training your ML model on this data before you actually deploy your solution into the new location. This helps you get started right away when that new location comes live. Generating large sets of identical images is not useful for ML training. Therefore, we need randomization of key parameters to create variability in the scenes and objects that the ML model can learn from. In our simulation, various parameters can be set by drawing from parameterized randomized distributions. If you look at these example images here, you can see different package mixes that are generated by one distribution, and it matches what we see in production. In our dataset qualification, we evaluate how well this process maps your real-world dataset. So let's zoom in on the quality of the produced labels. Within the simulation, the setup and placement of objects within the scenes are perfectly known. This information can be used to generate label data in much higher accuracy than human labelers would be able to do. And it's a fully automated solution, so we can reproduce this quality among even the largest data sets. Let's look at the labeling modalities some of you might have encountered in your existing setups. The easiest is certainly bounding boxes, which you see on the left here. This is where human labelers typically do well. If we talk about contours and segmentation, this will get a lot harder for human labelers. This means that we need tools to make this process easier, and we use them throughout other offerings within SageMaker Ground Truth. However, you're still spending a lot more time and effort on getting these labels. If we talk about depth labeling, for example, we're clearly leaving the realm of efficient human labeling. With the perfect information that our simulation engine has, we can even get parallel, simultaneous annotations for the same image. In the example you see here on the left, we want to actually label all the object instances of chicken nuggets as well as all the burnt spots on them. This will mean we're generating hundreds of labels per images. Human labelers typically get overwhelmed with that amount of work. Synthetic data generation will perform just right for all of these situations and deliver the highest quality of labels. Another problem that you're going to have in production is how do you train your model on the interesting but rare edge cases that are really influencing what your model learns. Your ML system in production will typically generate more images than your label capacity can sustain. At this point, you're starting to sample your data typically. This has two consequences. It's difficult to get examples of this, of these rare cases into your labeling pool, and once you have them labeled, you don't have enough of them to make a meaningful impact onto your model training. This is a method where synthetic data generation is really a game changer. We can generate a lot of data for these rare cases because we're simulating them. And we can scale this up to the quantity really needed to change the outcome of model training. To get started with SageMaker Ground Truth, I'll tell you what this will entail and how you can do that. There isn't usually a one-size-fits-all approach to ML project computer vision projects. This is why we made SageMaker Ground Truth synthetic data a service offering that accommodates your specific project and your specific needs. This means our experts will engage with you and get to know your project and your requirements. They will also produce the data sets for you to your specification. So what does that mean in practice? When you click on SageMaker Ground Truth, there's a new option, there's a new feature now for synthetic data. If you're interested to start your project with synthetic data, you engage by clicking on Open the Project Portal. After filling out a short questionnaire and submit it, and then our experts will come back to you and schedule a short consultation call to get all the project details and confirm them with you. In order to create digital assets and set up your scenes exactly the way you have them for your real-world data, we might ask you to provide additional data. This can be done using the project portal specific to your project. All data exchange happens securely via S3 buckets. Finally, after the data is generated, our data scientists will generate quality reports about this data set, and we will share both the data and the quality report to your S3 bucket for your review and approval. Additionally, we'll schedule a follow-up consultation call to discuss these results. When we create the data set, we roughly follow the following steps. We're working with you to define the project goals. Our digital artists will create assets, and based on your requirements and based on the objects you have in your scene. Our experienced operators will set up the scenes using the mechanism I discussed earlier. For example, they will set up lighting, background, and model the distribution of random variation within the scenes. Our synthetic data generation will then use these assets and the scene setups to generate the data sets. Finally, our data scientists will monitor the outcome and, if necessary, apply tools to make the generated data sets match your real-world data set. So how do we set up our scenes? We have a library of object controllers that we already implemented. They're available for your project. Because our framework is open and extensible, we can create new ones as needed for your project. Object controllers determine the location of objects within the final scenes. We've seen in customer use cases that for complex labeling cases, it might actually be required to adjust the digital assets for the specific labeling task in that project. We have interdisciplinary teams of artists and data scientists and engineers working together, so we can actually adjust the digital assets specifically for the needs of your labels. Finally, our data scientists are able to create detailed analysis of the generated data sets, and they can apply state-of-the-art methods to adjust the data set to match your real-world requirements. So here are some examples of what our data scientists look into. We've seen examples in previous projects where, to the human eye, the generated images looked very similar to what we had in the production data set. However, when we look into specific metrics, we're discovering a situation like the one you see on the left. The synthetic data and the real data is clearly distinguishable. That's not the situation we want. We're aiming for a situation that you see on the right, where the synthetic data and the real-world data is not distinguishable. If we encounter the situation like you see on the left, again, we have our interdisciplinary teams that can address these problems and fix them before we even share the data set with you. Alternatively, our data scientists can make small adjustments within their state-of-the-art tools to correct minor differences. We create a fidelity and a diversity report that tells us how close the synthetic data set is matching the real-world data set. Here's an example of what we're looking into. The diagram you're seeing here compares the distribution of image brightness values between the real data set and the synthetic data set. You can see we're doing a very good job of matching these distributions. However, in our report, we will also have a concrete metric value that shows us how well we're doing overall. As part of the report, you will receive this kind of evaluation for multiple metrics, including the distribution of object classes, object sizes, brightness, and contrast, and a whole host more of them.
Thanks, Herman. So let's walk through a couple of customer use cases. So for assembly and robotics use cases, we can create labeled data with variability for lighting, size, shape, and orientation for training robotics machine learning models. With manufacturing quality assurance use cases, we can simulate advanced manufacturing parts defects detection models. With autonomous mobility, we can simulate difficult scenes to improve the robustness of models used to expand autonomous robot capabilities. We can also create accurate labeled data for a variety of retail products for inventory management, in-store analytics, and autonomous checkout. We can tune food processing and packaging anomaly detection models for rare and difficult to acquire use cases. And lastly, we can generate labeled data to train various smart home applications. And we're just getting started. For assembly and automation use cases, we create large amounts of labeled data with variability for lighting, size, shape, and orientation to support robotics training models. This enables our fulfillment centers to automate repetitive tasks through perception automation. Our custom synthetic training sets are used for pick-and-place robots by +1 and Amazon Robotics to help them keep up with changes to package size, color, and shape. Sean Edwards, the CTO and co-founder of +1 Robotics, told us that we use Amazon SageMaker Ground Truth to generate tens of thousands of labeled photorealistic images of packages from various carriers, modeling pose, placement, and even surface variations like stickers and labels. And this data is used in real-life induction applications to facilitate over 1 million picks per day for our customers. We've also been working with Tyson Foods to train and tune their processing and packaging anomaly detection models. Synthetic data allows them to replicate rare and difficult to acquire edge cases such as burnt and misshapen chicken nuggets on the production line and without intentionally burning food or creating malformed nuggets. The initial attempts to capture real-world images were foiled by obscured camera lenses and camera blur due to the high speed of their conveyor belts. Our synthetic data enables us to replicate those rare defect edge cases so that Tyson Foods can train imperfect food detection models and identify defects without interrupting the production line. Barrett Miller, who's a senior manager of emerging technology at Tyson, noted, "We often run into a bottleneck of collecting and labeling training data specific to our processes and environment. In some cases, labeling is very tedious and error-prone, and this leads to poor machine learning model performance. In other cases, it's very difficult or impossible to collect and label the images." Amazon SageMaker Ground Truth holds tremendous promise for us because it allows us to address every one of these challenges. It can reduce the turnaround time for label data, enabling us to train models faster while also improving accuracy. It's opening up paths for us to tackle use cases that were all but impossible to address with computer vision in the past due to lack of example data. And with that, we invite you to submit your project in the console today. Reach out to one of your account managers, learn more about how synthetic data works with SageMaker Ground Truth, and augment your training data sets to improve your machine learning model performance. And thank you.